You've probably driven past a wind farm and noticed something. Every single turbine spinning against the sky has 3 blades. Not 2, not 4, not 5. Always 3. But why? Why not build them with more blades to catch more wind? Wouldn't that generate more power? And if 3 is the magic number, why do old-fashioned windmills have so many more? What you're about to learn isn't just about efficiency, it's about a hidden balance that engineers spent decades trying to perfect. Here's what most people don't realize. The goal of a wind turbine isn't to catch as much wind as possible, it's to convert wind into rotation as efficiently as possible, and those are 2 very different things. If you put too many blades on a turbine, something unexpected happens. The blades start blocking each other. The wind that hits the first blade creates turbulence, a swirling mess of air that disrupts the blades behind it. More blades means more interference. You're not gaining power, you're losing it. But if you use too few blades, say just 1 or 2, the turbine becomes unstable. It wobbles, it vibrates. The forces become uneven, and over time, that tears the machine apart. So the problem engineers faced wasn't about catching wind, it was about finding the perfect balance between power, stability, and cost. The answer is something called the tip-speed ratio. It sounds technical, but it's simple. It's the speed at which the tip of the blade moves compared to the speed of the wind hitting it. Modern turbines are designed to spin fast. The tips of those blades can move at over 180 miles per hour, even in moderate wind. At that speed, 3 blades are enough to capture nearly all the energy available in the wind. Adding a 4th or 5th blade doesn't increase power, it just adds weight, cost, and drag. 3 blades also create something called rotational symmetry. The forces are evenly distributed. The turbine stays balanced, there's no wobble, no destructive vibration. It spins smoothly for decades. And here's the part that surprises people. 3 blades aren't just efficient, they're also the cheapest option that still works at this level. 2 blades would be cheaper, but they'd need heavier, more expensive support structures to stay stable. 4 or more blades would cost more to build and maintain, with no real gain in power. 3 is the sweet spot. Think of it this way. Imagine you're paddling a canoe. If you use 1 oar, you spin in circles. If you use 2 oars on opposite sides, you move forward, but it takes effort to stay straight. But if you had 3 oars, evenly spaced, your strokes would be balanced. You'd glide smoothly with less effort. That's what 3 blades do for a turbine. They create balance, momentum, and efficiency all at once. Now compare that to the old windmills you see in the countryside, the ones with dozens of wooden slats. Those weren't designed to generate electricity. They were built to turn slowly and grind grain or pump water. Slow rotation needs more blades to generate torque, the twisting force that does mechanical work. But modern turbines don't need torque, they need speed. And speed comes from fewer blades moving fast, not many blades moving slow. 3 blades give you maximum energy capture without wasting material. They reduce mechanical stress, which means fewer repairs. They operate quietly because the blades slice through the air instead of chopping it. They're visually stable, which matters more than you'd think because a wobbly turbine makes people nervous. And perhaps most importantly, 3 blades make wind energy scalable. You can build thousands of these turbines, ship them anywhere, install them quickly, and know they'll run efficiently for 20 years or more. The 3-blade design didn't happen overnight. In the 1970s and 80s, engineers tried everything. 2-bladed turbines were cheaper but noisier. 4- and 5-bladed designs were tested, but they didn't justify the extra cost. Some experimental models had vertical blades, or blades that changed pitch mid-spin. But by the 1990s, the 3-blade horizontal axis turbine became the industry standard, not because it was trendy, but because the math, the physics, and the economics all pointed to the same conclusion. Today, over 90% of the world's wind turbines use this design. From the plains of Texas to the coasts of Denmark to the mountains of China, the 3-blade turbine has become the universal symbol of clean energy. So the next time you see a wind farm, you'll know Those 3 blades aren't random. They're the result of decades of testing, failure, and refinement. They represent a perfect trade-off between physics and practicality. 3 blades, not because it's easy, because it works. If you found this interesting, take a moment to notice the small engineering choices around you. They're everywhere, quietly shaping the world.